way anybody who watches that we're recording now. So you're asking about the exam.
Yeah.
The exam will be, yes, it'll be open all of next week. So you can take it whenever you want next week. About 50 minutes to take it. And the review probably sometime at the end of this week, because the review is not mandatory. So we're not going to take class time to do a review. What I'll do is I'll say, hey, I'm going to be online at this time, and I'm going to go over the study guides and give you guys the answers.
So I know when you say it's on here, it's in my notes.
Yeah. What's the review?
No, for like, okay, this you might see this on your test.
Oh, yeah, exactly. Yes. So yeah, and when I go through the study guides, I'll say, this definitely won't be on the exam. This might be on the exam. This definitely will be on the exam. And I'll give you some examples sometimes of how we word the questions. So the exam reviews are important. I would attend or watch the video. Yeah. So even if you can't make it, watch the video. And normally it would be 3 chapters and then the exam. But the way this textbook works, what used to be 2 chapters is switched into chapter 2. So what we're learning right now, even though we're still in the middle of chapter 2, we were in the old textbook. We would be starting chapter 3. All right. So since we're recording, I'll go ahead and say it out loud for attendance. We have Young, right?
Yeah.
Okay. We've got Crystal and Ashley. Like I said, you all have a little extra credit for being on a little bit early. And since I'm recording, if you're online, either live or watching the video later in the day, from now on, online is only going to get you 2 out of 2.4 points. So it's still a majority of your points, but not full participation points. And of course, you can make up for that with extra credit by coming in this case, being early or during WBS stuff on Wednesdays or red stuff on Fridays. And we have Vargas. He's also here early, a little bit of extra credit. And some of you, if you're missing a day, if you have absences, you can still watch the videos because at least one of you here I have is absent for Friday. It's a weird day because of the change of venue. But anyway, you can still.
That could be me. I woke up, the storm scared me, and it sent me back to sleep, and I never woke up to my alarm. It was a bad storm.
That is okay. That's why I do the videos. I mean, again, you don't get full credit, but some credit is better than nothing. Plus, it's important, I try not to repeat myself too much in this course. And to understand today's information, for example, you needed to have Friday's information. So whenever you guys miss class, I highly recommend watching the video, not just for the participation points, but so you understand what's happening in class. But the good news is, for those of you who missed class on Friday, it was really short. So technically you didn't miss much. We are recording, so if you guys have questions, let me know. Did anybody travel for the weekend? Do you guys travel? No. Either. You guys watch any sporting events over the weekend?
Next Saturday.
Yes. I love college football. It's my favorite sport. Obviously, WBSU would be my #1 team because you got to support your employer and your alma mater. But beyond that, I think my favorite team would have to be Florida State University because that's where I'm from and that's where I met my wife. What's your team?
What's their name?
Other than WBSU, yeah.
WBSU, WBU.
So nobody with a national championship.
That's
Morning, everybody. Got a little bit more than 3 minutes. And we're recording. So again, if you guys have questions about biology or the course in general or whatever. So technically the pre-labs are past due now for lab 2. And the labs now are technically past due. But, that was Friday. I'm saying technically, because I haven't gotten around to check, grading the body. So if you haven't done last week's lab, this week's pre-lab, you really want to get that done after this lecture. That's always I can help you. Also, technically, you should have 10 points of independent work by today, by last night. Further announcement. So earlier, before some of you got in here, someone was asking about the exam. The exam will be posted. It'll be open all next week. So you'll have any time you want to take it next week. 15 minutes to take about 50 questions. To answer about 50 choice questions. They're based on the study guide. Some of them are verbatim from the study guide, but most of them are reworded. Hey, you brought in some cans for 5 points. I'll see those there. Thanks. What else for minors?
Did you see that article on CNN yesterday about the ghost heart?
No, what? Ghost heart?
It's from a pig and they're using patient cells.
Oh, no.
I'm ready.
Huh. I'll look into that.
It's ready for transplant into humans.
It's amazing. So they use like the patient's cells?
Yes.
Make it make sense. Very cool. So yeah, exam next week. 50 minutes to take about 50 questions. Answer about it. If you want more time, let me know. We can meet either in person or online. If I can ensure you are taking a closed book exam and not use the internet or your notes for the book, and I don't care how long it takes you to take. The only reason that's a timed exam is because you're supposed to be a closed book exam. And honestly, you just don't have time to look up 50 questions in 50 minutes. That's the purpose behind it. And for those of you who found my one-on-one class, you know that the questions can be worded very oddly. It's also because people before you have cheated. So there's apps out there where you can take a picture of a question and it will give you the answer. And I have that app and I take a picture of all my questions to make sure the answers don't pop up. So I have to confuse the app. I have to confuse the artificial intelligence by using really oddly worded questions. Which is another good reason why you might want to take it online with me. 1, to get rid of the time limit. And 2, if you need me to clarify a question like, what the hell are you asking? You can ask me to clarify a question. I'm here for you. All right, less than a minute. So let's do some attendance. Brian, Curry, Darby, Fisher, Hamilton, Elman, gotcha. Ashley's here, Crystal's here, and Taylor's online. Moody, Newsom, Norris. Good. Poor, Rollins, Ruffin, Saunders. Saunders. Lee, Shamblin, Hawaii, sport reasons. Sherman, Taylor Pierce, Thompson, Valdez, Vargas is here. Winfield, I know Young is here, so did I miss anybody? It's 8 o'clock. Let's get started. Try to stay awake. It's a Monday. It's dark outside. It's dark in here. It's really cozy. But speaking of staying awake, as always, you guys can send me the attendance words, you guys, for extra credit. And for those of you online, you'll need to send me the attendance words for regular credit. But Brian, right? Yeah. Okay. Time. So I guess the first word for attendance will be cloudy. Like it's cloudy outside. And let's jump back into chapter 2. And well, before we do, again, does anybody have any questions? Biology, the course itself, like that. All right. So to remind you what we're talking about now, we're at the end of chapter 2. We're discussing these 4 categories of large biological molecules: carbs, lipid proteins, and nucleic acids. On Friday, we talked about polymers and monomers. That's going to be the discussion throughout all of this, because a lot of the exam is going to be identifying, if I give you the monomer, you should be able to tell me the polymer. Or if I give you the polymer, you should be able to tell me the monomer. So as you're learning this, keep in mind, you're going to need to know the monomers, the carbohydrates, and the polymers, the proteins, and so on and so forth. And to remind you, a polymer is just a bunch of things put together that are made up by monomers, right? It's basically repeating molecules. So, and I think I use the analogy of a pearl necklace, right? The pearl necklace would be the polymer. Each individual pearl would be the monomer. So that being said, let's jump into it. First thing we're talking about is carbohydrates. You don't necessarily need to write anything down from this slide. It's just kind of an introduction. But just so you know, carbohydrates include sugars and polymers of sugars. And again, there's no need to write that down because we're going to get really specific. So I'm going to give you some specific sugars, and I'm going to give you some specific polymers. That's the stuff you know. It's just an introduction. And I like this picture. It's a great example because here in this Coca-Cola, you probably have high fructose corn syrup, which is the type of sugar. Obviously, in that pasta, you have starch, and that is actually a carbohydrate made up of a bunch of sugars. And we'll learn all about all of that in this portion of the chapter. Here's something you need to know. In plants, we'll start with animals. In animals, carbohydrates are the primary source of dietary energy. You do need to know that for the exam. So again, we're talking about carbs, proteins, nucleic acids, and fats, right? So those would be the choices on the multiple choice exam. I'll say, which one of these is a primary source of dietary energy for animals? And the answer will be carbohydrates. And of course, obviously, anything you eat that can be digested is a source of energy. So also proteins and fats and nucleic acids are also sources of energy, but the primary source is carbohydrates. Now, of course, these are also the raw materials for building up molecules. That comes from your textbook. Honestly, if I were taking notes, I wouldn't even write down that second bullet point. Because honestly, everything you eat that can be digested is the raw material for building up molecules. That's why you digest it, to get the energy out of the molecules and to get the raw material, building blocks, build other stuff. But yes, in animals, that is the main source of energy. So any questions about that bullet point? All right, in plants, it is the building material for much of the plant body. And I'm going to get specific later in this section and tell you exactly which molecule is the building material. But if you get a question on the exam that says which these 4 is the building material for plant cells, for plant bodies, for plants, the answer will be carbohydrates. Again, I'm going to tell you which carbohydrate shortly. So are there any questions about this slide? So again, this whole section of the chapter, we're talking about carbs, proteins, nucleic acids, and lipids, right? At this moment, we're talking about carbohydrates. Carbohydrates themselves are also broken down into different categories. You need to know these categories. The first one we're going to talk about, monosaccharides. Speaking of which, the monosaccharides are the monomers. Remember I said you need to know the monomers and the polymers? Well, the monomers are carbohydrates are monosaccharides. For carbs, it's easy. It's in the name, right? Monosaccharides and monomer. Easy. It'd be even easier if instead of calling them carbohydrates, we call them polysaccharides. And we'll get to that, but we also, again, obviously call them carbohydrates. So these monosaccharides cannot be broken down into other smaller sugars. So if you have a thing of glucose, you can break it down. technically, once you break down that glucose, it's no longer sugar. So this is the base, right? Again, it's the monomer. Not that I'm going to test you on this, but usually the name of a monosaccharide ends with an OSE, like os, glucose, fructose, which that's not a monomer, but talk about that too. Yes, it is, sorry. Glucose, fructose, lactose, right? Those all end with an OSD. Another thing I'm not going to test you on, but it's in your book, so I'm presenting it. They're often categorized by the number of carbons, right? So if it's a 3-carbon sugar, it's trisoses, pentoses if it's 5, hexose if it's 6. Not going to ask you about that, but again, it's in your book. It's a 100 level course, so I like to teach out the book. I'm also not going to ask you these common examples, but here they are. You have glucose in sports drinks, so Gatorade has glucose in it because you need glucose, right? Like I said earlier, that's your primary source of energy. So that's the purpose of those sports drinks, right? To give you energy, keep you hydrated. There's fructose in fruit, so that's the stuff that makes fruit sweet. And then both of these, glucose and fructose, can be found in honey. So again, these are just examples. Here's a picture of glucose and the fructose that's found in honey. You don't need to know anything about that. I'm not going to ask you about glucose. I'm not going to ask you about fructose, but you do need to know this word right here, isomer. So an isomer is a molecule that has the same chemical formula, but different arrangements. So you can see here, this glucose is C6H12O6, right? 6 carbons, 12 hydrogens, 6 oxygens. This fructose is also 6 carbons, 12 hydrogens, 6 oxygens. But you can see they're different. Not that you even need to know how they're different or what it means, but yeah, technically these are different. And that is called an isomer. You need to know what an isomer is. So generally speaking, when you see that prefix in this class, iso, you should think the same. Right? In this case, the thing that's the same is the chemical formula. Just like isotopes from earlier in the chapter, right? That they have the same number of protons, but different number of neutrons. So an isomer has the same chemical formula, but a different structure. And you can look this up if you want. Other than the fact that they have a different structure, what is the difference between glucose and fructose? Easy independent work topic for you. 2 sentences at most. Because they do taste a little bit different because we have different receptors in our tongues. So that sugar tastes a little bit different than that sugar. So you can look it up. Which one's sweeter? Do they have the same calories? Things like that. Anyway, any questions about this? Once again, you do not need to know the difference between glucose and fructose, but you do need to know what an isomer is. So again, there it is in writing everything I just said. Glucose and fructose are isomers. Not that you need to memorize the fact that glucose and fructose are isomers, but you need to know that isomers are molecules that have the same molecular formula, but different structures. So any questions about isomers? Here's a good example. How many of you guys have seen the show Breaking Bad? Just one of you? Okay. But this really is a good example, and I think this is the example he used. So those things look, even though you guys aren't chemists, you can just look and see that those things are very similar, right? This is like a mirror image of that. So they have the same chemical formula, but a different structure. Like I said, they're mirror images of each other. And that's important. Excuse me. Let me check something real quick. I heard a noise online. Make sure everything's okay there before we keep going. Sorry, I got about this, guys. That was had another person join us. That's all. Okay. Anyway, back to it. Yeah. So one of them, this molecule is something that you would find in big steak rub, things like that. It's basically menthol, basically. And the other one is the stuff that's used to make meth. Right. So completely different things. One of them is good for you. One of them is bad for you. And they're the same chemical formula, but a different structure. And again, that's another good independent work topic in my opinion, if you want to put that up. What are some other examples of isomers where one of them is good for you and the other one's not? Anyway, any questions? Obviously, this is just an example. I'm not going to ask you about that on the exam. Speaking of which, I guess that'll be the next attendance word. Meth. So send me the word meth. Don't actually send me any meth. We'll both get in trouble. So, still talking about monosaccharides. Specifically glucose. This is the main fuels for cellular work, but there's definitely no need to write that down. We're going to have a whole chapter on that. You're definitely going to know about glucose after we're done talking about cellular respiration. So in a sense, this is almost just like a foreshadowing, like giving you a hint give you a glimpse of what we're going to get into later this semester. And also, not that I'm going to ask you about this, but a lot of times these monosaccharides form rings when they get wet. That's not necessarily important, at least for the exam. But I would say the only reason this would be important for you to know, again, this is what it looks like when it's not in a ring structure, but sometimes when it gets in the water, it forms a ring and looks like this. The only reason that would even be important for you is because, again, we're talking about monomers, right? The monomers make up polymers. So when we put these monomers together, this is what we're putting together. It's a bunch of rings of glucose molecules. Not that I'm going to go into that much detail in the exam. There you go. Now you know. When we start talking about these polymers of these monomers, now you know how they're put together. They're little rings. So anyway, any questions about that? All right, that's it for monosaccharides. Let's see if anybody can guess what we're going to talk about next. Just use some common sense and think about what words mean. If we're done talking about monosaccharides, what might come next? I love it. And that is next, but there's actually one, but it's not very next. So we will talk about polysaccharides. There's one after, there's one in between. So after monosaccharides, any guesses? Because I love it. You were on the right track. What might come after monosaccharides? All right. How many of you are math majors? None. Okay. So this is a tricky question. What comes after one? Two. There you go. Good. We should give you an honorary math degree. Yes, two comes next. Any idea what you might call two? What the prefix might be in biology for two? Bi is one of them. Di is the other one. So yes, disaccharide. Disaccharides are consistent of two sugars. Two sugars put together is a disaccharide. When people say sugar, it's usually what they mean. Mom says, "Can you please pick up some sugar from Kroger?" This is usually what she means. Right? Table sugar is sucrose. Speaking of which, sucrose, lactose, maltose, those examples you see on the slide, you don't need to memorize them. I'm not going to ask you to memorize the fact that sucrose, lactose, and maltose are disaccharides, while glucose and fructose are monosaccharides, right? What we talked about earlier. You don't need to know those examples. Just know monosaccharides are one sugar, disaccharides are two sugar. Actually, I take that back. If there might be one you would need to know, and that's sucrose. I might ask you about sucrose. Because again, that's table sugar. When people say, I need some sugar for this recipe, that's what they mean. So know that sucrose is a disaccharide. And obviously in the name disaccharide, it's two sugars put together. What you don't need to know, even though your book mentions it, like I said, sucrose is two sugars put together, right? That's glucose and fructose put together. I'm not going to ask you that much detail. So any questions about the slide? Okay, if you download the PowerPoint, which has been fixed, I remember somebody was asking about that last week. Watch this little animation that shows these things coming together. And this is a good time to quiz you, so to speak. What would we call it when we put this thing and this thing together? What kind of reaction is that? See if anybody remembers, because you'll need to know it for the exam next week. When you put two things together in this class, we always have it, we always call it the same thing. And here's a hint. It forms water when it happens. You're kind of squeezing water out of the product or out of the reactant, so to speak. So what kind of reaction is this? Any guesses? All right. To remind you, that's a dehydration reaction. That will definitely be a test question. And we'll be talking about it a lot in this semester. So when you bring two things together, that's a dehydration reaction. The opposite would be true if we were to break up this lactose to make glucose and lactose. You break it, that would be a hydrolysis reaction. But anyway, this is just an example. You do not need to know that lactose is made up of glucose and lactose. But again, this is a good time to remind you that when you bring things together, that's a dehydration reaction. And again, your book gives these examples. You can find lactose in milk, you can find maltose in beer, or malted milkshakes, or malted milk candy balls, whatever. And again, sucrose and table sugar. But I'm not going to ask you any of these. And if I did ask you anything, it will be this right here. Know that sucrose is table sugar. Right? When we say sugar, people use the term sugar. That's usually with it. And now you know that there's actually other kinds of sugars, right? Same thing with salt, right? We talked about salt. Salt, when we say salt, we usually mean sodium chloride, right? The stuff you put on your food. But there are other salts out there. Anyway, any questions about this slide? So extra credit for anybody who brings me beer. I'm just kidding. And I'll take some beer, but can't give you extra credit for it. It's a dry campus anyway, so don't do that. Anyway, again, sucrose is the main carbohydrate found in plant sap. So again, that's where we get sugar. Little known fact, most sugar does not come from sugar canes. You can look that up for a bit work if you want. I was about to tell you what it is, but it's not important for the semester, but it's trivial. You can look it up. Where does most sugar come from? When you buy sugar, where did it come from? I don't mean geographically, I mean like what plant? So I'm also not going to ask you about high fructose corn syrup, but it's so prevalent in our diets that I think we should talk about it just for your own knowledge. That is made by a commercial process that actually turns glucose into fructose. So most high fructose corn syrup didn't come from fructose. We took glucose and we changed it. Remember, those are isomers, right? So they changed it up a bit to make it into fructose. And now you know fructose is sweeter than glucose, because I mentioned earlier you can write stuff about that. The difference between fructose and glucose, there's one of the differences, it's sweeter. So that's why people do it. It's also a lot cheaper. Which again, if you're in the business of making money, you don't want to use that instead. Anyway, it's often one of the first ingredients listed on soft drinks. And in case you didn't know, when you look at a list of ingredients, it's by volume, so to speak, right? So whatever's the first thing on the list, there's the most of that. Second thing is the second most, so on and so forth. So obviously, it's mostly high fructose corn syrup. Anyway, again, I'm going to move forward. These little pictures talking about, it kind of explains what we're talking about. We take corn. When you think of corn, hopefully you think of starch. Starch is made up of sugar, specifically glucose. So they break down starch into the glucose, and they take that glucose and they convert it via an enzyme, and we'll talk about enzymes later in this chapter, actually. And then you get fructose, and then there you go. So any questions about this? Again, this is just for your own knowledge. I'm not going to ask any questions about it. And the next thing I'm going to tell you is also not in your textbook, so I'm not going to test you on it. But it is worth mentioning because, again, this is our diet. It's stuff to eat. According to your old textbook, the average American consumes about 130 pounds per year of sugar. And it's mostly high fructose corn syrup. It's a major cause of tooth decay and overconsumption, and it increases your risk of type 2 diabetes and heart disease. And basically, it's empty calories. So yes, you're getting the calories, but you're not getting any other nutritional benefits from it. This is a good topic for independent work. See, like your old textbook, the old textbook was pretty old, so you could look that up. According to the old textbook, it was about 130 pounds a year. Is it still about 130 pounds per year? We're eating more, we're eating less. Is it still the same? And if you want, try to figure out how much you eat. Just track your diet for a week, maybe, and then extrapolate. Like, I eat this much sugar this week, therefore I probably eat this much per year. Anyway, again, none of this will be on the test. You guys have any questions about this? Okay, so we're done talking about monosaccharides. We're done talking about disaccharides. There are no trisaccharides. So what's the next one? Someone's already said it. I think it was you. Polysaccharides are next, yes. So when people say carbohydrates or carbs, this is usually what they mean. I think, that's my opinion. Every time I hear people say carbs, this is usually what they're talking about. These are complex carbohydrates. So polysaccharides are complex carbohydrates. That might be a test question. Test question might say, which of the following is a complex carbohydrate? And the options are probably polysaccharide, monosaccharide, disaccharide, probably somewhere I just make it up. And again, these are the polymers. So finally we got to the polymers, right? You know already that monosaccharides are the monomers. Now finally I'm telling you that polysaccharides are the polymers. Nice and easy, right? Monosaccharides, the monomers, polysaccharides are the polymers. The only thing you really need to memorize for the exam is this saccharide. When you hear saccharide, you should think sugar, the carbs, right? Make sure you don't confuse those with proteins, nucleic acids. or lipids, all the stuff we're going to talk about later. So any questions so far about what polysaccharides are? All right, if you download the PowerPoint, again, you can watch this animation that shows a bunch of monomers coming together to make the polymer. Again, bringing two things together, that is a dehydration reaction. So there's different types of polysaccharides, and you do need to know these. So the first one is, well, actually, let's see if anyone can guess. So like I said, it's complex carbohydrates. So just think about what you eat. What's something that you eat that's a carbohydrate? You think of carbs, what do you think of? Bread, good. And what is it in bread? Do you know? Not that you need to, this isn't a diet class, but it's starch. So you need to know starch is a polysaccharide. Technically, it's a long string of glucose monomers, but technically everything I'm about to teach you is a long string of glucose monomers. So I guess if you take a note, you wouldn't necessarily write that down, because that does not make starch unique. What does make starch unique, and something you need to know, is starch is used by plants to store energy. So know that. Middle bullet point, as far as the exam is concerned, is to all make it important. You need to know that starch is used by plants to store energy. And that will get confusing. Some of you will miss that question, especially if you are ever into running. You've ever done carbo loading. You think, all right, well, I'm going to eat a bunch of starch the night before this race, so I have some stored energy. So don't confuse the fact that we eat starch to get energy with the fact that starch is used by plants to store energy. Just focus on the fact that starch comes from plants. If you can remember starch comes from plants, then hopefully you can remember that it's used to store energy. So anyway, any questions about what starch is? All right, here's a picture of some starch. Again, you can see it's just a bunch of monomers, right? So there's a glucose, 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 right? It's a bunch of monomers, a bunch of glucoses linked together, and that's what it looks like. All right, the next one we're going to talk about. So again, starch is used to store energy in plants. What do you think? Again, it's not showing you. What do you think glycogen might be used for? The starch is used by plants to store energy. What do you think glycogen is used for? Yeah, yes. I guess that's okay. Since we're done talking about plants, glycogen is used by animals to store energy. So glycogen is basically the animal version of starch. And if you look at it, it's really similar, right? This looks just like starch. The only difference between this structurally is that it also branches off, right? So instead of just having one string, it just branches off. So yeah, that's what we use to store energy. That's the important bullet. This other stuff, I'm going to tell you about it, but I'm not necessarily going to ask you about it. This is stored mostly in the liver and the muscle cells, right, where it's going to be needed. And how is it used? Glycogen is broken down to release the glucose. So again, the glucose is where we get the energy. The glycogen is just how we store it. Same with the plants. Plants need the glucose, but they store it in the form of starch. This is another good independent work topic, right? So how does that work? When we eat sugars, do we then build it into glycogen, or do we convert it another way? So all things you don't need enough for the exam, but you can look up for it a bit. Or when we eat an animal, like if we're eating muscle cells, right? When you eat steak, you're eating muscle cells, for example. Obviously, there's going to be glycogen in there. So do we just take that glycogen? Is it just stored in our liver, or do we convert it first to do things to it? So you can look that up for independent work if you want. But anyway, any questions about glycogen? So again, basically, starch is how plants store energy. Glycogen is how animals store energy. You guys need to know that. This next one is not about energy at all. It's called cellulose. You need to know what cellulose is. I might ask you this, but it is the most abundant organic compound on Earth, right? And here's what you really need to know is actually none of that really. Maybe the bottom. Fiber. So when people say you're eating fiber, this is what they're talking about. So cellulose, and I don't know why it's on the slide, I apologize. Cellulose is the stuff that plant cells use to make their cell wall. That's why it's the most abundant organic compound on Earth, because you see a plant, even though it's green, This isn't green. Which you're mostly looking at is cellulose, right? Most plant cells are made up of cellulose. So it's very important. And again, it's good for you. It's fiber. Why is it good for you? This bullet point here, even though I'm not going to ask you about it. Cellulose cannot be digested by enzymes produced by most animals. So when you eat cellulose, you cannot digest it. So it doesn't, there are no calories. It's just long strands of glucose, and it just goes through your body undigested, and that's what helps clean you out, basically. Because it's long and not digested, so it helps keep you regular, so to speak. I guess the next word for attendance on a semi-related note will be toilet. But yes, fiber. Fiber is good for you. And I found this picture on the internet, so I wanted to share it with you. Not that you need to know any of this. First of all, let me go down the record and say fast food is bad for you. I'm not defending fast food. However, there's a lot of garbage on the internet and social media where people try to trick you. And I mentioned this earlier in the chapter, where people give you true information but present it to you in a scary way, trying to make it sound scary. So, speaking of this, where is it at? Yes. It says, what's in your fast food? And here it says there's wood, parentheses, cellulose. And that's misleading. So wood is made up of cellulose. But again, cellulose is fiber. It's good for you. When you eat lettuce and even potatoes or any plants, right, you're eating cellulose and it's good for you. So in this case, they're trying to make it sound like there's wood in your food, and there's not. There's cellulose in your food, which happens to be good for you. And there also happens to be cellulose in wood. So again, a lot of misinformation on the internet. And this is good. This is why you're getting a college degree. So people, you won't be so easily fooled. Not that this is very important for your everyday life, but again, there's a lot of misinformation. People are dumb, and these people vote, and these people sit on juries. So it's important to not be dumb and not be easily tricked. But anyway, back to cellulose. Again, it's a long string of glucose monomers. You can see it looks a little bit different because remember, starch was all zigzaggy. This is straight. Not going to ask you about that, but there you go. Any questions about cellulose? All right, there's one more polysaccharide you need to know, and it is called chitin. And it's a nitrogenous carbohydrate. Not that I'm going to ask you about that. But basically, when you think of chitin, you should think of arthropod skeletons. So what are arthropods? Usually people call them bugs, right? So shrimp, crabs, spiders, grasshoppers, whatever. So again, now that we've talked about all of them, let me put it all on one slide here. That's all of them right there. Starch, glycogen, cellulose, chitin. You need to know the differences between them. The most important stuff here is that, again, starch is used to store energy in plants. Glycogen is used to store energy in animals. Cellulose is used for structure in plants, and chitin is used for structure in some animals. Honestly, I'll probably be less likely to ask any questions about chitin. Because the other stuff we're going to talk about later, like starch comes back, glycogen comes back, cellulose sort of comes back. But anyway, are there any questions about this slide or about polysaccharides in general? Okay, here's some pictures, more pictures of it. So that's it for carbohydrates. No questions about carbohydrates? Move on to the next main category, which are lipids. And you can see a picture here, so that's a good hit. But what do you guys think lipids are? Guesses of what a lipid is. And there's a good hint. Actually, before we begin with that, let me back it up a step. First of all, something I didn't tell you about carbs is that they are hydrophilic. You need to know that. Carbs are hydrophilic, meaning they love water. Also meaning that they dissolve in water. Technically, they don't love, right? Carbohydrates don't have emotions. But just for your own knowledge, the reason that they are hydrophilic, the reason that they can be dissolved in water is because they are polar. Those molecules are polar, like we talked about earlier in the chapter. And water is polar, right? So there's that slight charge, and water can dissolve it. So there's a slight charge to those molecules. So that's what carbs are. Lipids, on the other hand, are hydrophobic. So before we even talk about what lipids are, you just need to know that they're hydrophobic. So they can't mix with water. That's why I have this picture of oil and vinegar. Oil is a lipid. Vinegar As far as we're concerned in this discussion, might as well be water. I mean, it's not, but as far as we're concerned, might as well be. And that's why it separates. Now, if you shake it up, like you would salad dressing, right? You shake it up, it looks like it's mixed. It's not technically mixed. It's what you call emulsified. Not that I'm going to ask you about that on the exam either. But technically, when you shake it up, what's happened is there's just little beads, little tiny bubbles of the oil mixed in with the vinegar. So it looks to you, your eyes, it looks like it's mixed, but it's technically emulsified. Anyway, carbs, hydrophobic, lipids, carbs, hydrophilic, lipids, hydrophobic. You need to know that. So then it's pretty simple though, right? Any questions about that before we move forward and start talking a little bit more about lipids? All right. You don't necessarily need to write this down. This is just for your own information. The lipids are unique. They're different than the other three that we're going to talk about. They're different than the carbs and the proteins and the nucleic acids because carbs, proteins, and nucleic acids are technically polymers that we talked about, right? They are made up of repeating monomers. So in the case of the carbs that we just talked about, it's a bunch of glucose, right? And starch, it's a bunch of glucose. Lipids are not like that. So they don't have repeating monomers. They are made up of smaller pieces, but they're not made up of a bunch of repeating monomers. So for the exam, there will be no what monomer is this or polymer is this. We're talking about lipids because technically there are no monomers and polymers for lipids. So what are lipids? They are a diverse group of molecules made from different molecular building blocks. No need to write that down. We're going to talk about different types of lipids, and you're going to need to be able to identify one versus the other and know the differences between them. The first one we're going to talk about is probably the one you're already familiar with, which is fat. So when you think of lipids, then you could think of fat, right? Typical fat, aka triglyceride. You need to know that. So when I say triglyceride, I mean fat. When I say fat, I mean triglyceride. I'm probably not going to ask you this, but just so you know, and just so the name makes sense to you, why they call it triglyceride. It's a glycerol molecule, which I'm going to show you a picture of later, attached to 3 fatty acid molecules, and that's where it gets its name. The fatty acid part, that's where you get the energy, right? So obviously when you eat fat, it's very energetic, and that's why, because those fatty acids have a lot of energy. I'm also not going to ask you this, but just so you know, fats have 2 times the energy of carbs, so they're much more energetic. Where are they stored? Adipose cells. So usually when people say fat, that's what they're talking about. These unfortunate adipose cells. Mine have been growing over the summer. It's too hot to run. Fall's coming. Try to shrink it. Anyway, again, what you need to know is that a triglyceride is a type of lipid. It's also called a fat. That's what you need to know for the exam. The next slide I'm going to show you, we're going to go into a little bit more detail about the structure. But yeah, any questions so far? All right. Again, if you download the PowerPoint, you can watch this little animation. And what you'll see is this glycerol molecule being attached to these 3 fatty acids. What kind of reactions are those? Those are dehydration reactions, right? Anytime you build something in this course, anytime we talk about bringing molecules together like this, that's a dehydration reaction. Anyway, yeah, so that's what it looks like. Glycerol molecule and 3 fatty acids. Notice too that these fatty acids are straight and this one's curved. Also notice that this one is longer than this one. That's not trivial. We're going to come back and talk about that here in a second. You don't need to memorize that, but the fact that they have different shapes will be important here in a second. So when you think about fat, what do you think you use fat for? Why do you need fat? Not your diet, but what does your body use fat for? And that picture is a hint. How does your body use fat? What do you use fat for? No guesses?
Insulation.
Good. Insulation's one. And that picture's not a good one, so I'm glad you guessed that. Yeah, right? Like, especially for like seals or aquatic mammals, right? Insulation, fat, blubber, helps keep you warm. Yes, that's one of them. There's 2 more. Any guesses?
Cushion.
Good. Cushion, right? That's what that picture does, right? You have fat on the soles of your feet for cushion. I had to put a picture of that instead of something, but again, same purpose, right? Cushion. And then does anybody know the other one? Like when I'm fat, I gained all this weight over the summer. Why did my body store this fat? energy storage, right? So that's how we store energy. I might ask you those three things. So what are fats used for? What are triglycerides used for? Energy storage, cushioning, and insulation. I probably won't ask you, but I might. Any questions about that? All right, this next slide is more important. There will definitely be test questions on this. You need to know the difference between an unsaturated fat and a saturated fat. So really the first question is, when we say saturated, what do we mean by saturated? Saturated with what? So if we're not in biology class, speaking of running, if we were not in biology class and I came in for a long run, my shirt, just really sweaty, my wife said, hey, your shirt is saturated. What does she mean by that? If I were to come in from a long run, all sweaty, she said, hey, your shirt is saturated. What does she mean? Yeah, it's wet, right? And that term, that usage in that context means it's soaked. Like this literally can't hold any more sweat, right? It's saturated. It's absorbed as much sweat as it can. So in this situation, saturated means there's as many hydrogens as possible on that molecule. So it is saturated with hydrogens. You need to know that. That would definitely be a test question. What are saturated fats saturated with? Hydrogen. Not water, not flavor. Hydrogen. Saturated fats are saturated with hydrogen. Now, let's talk about why that's an important distinction. Because when they're saturated with hydrogens, they're straight, right? These unsaturated, they're not saturated with hydrogens because they have double bonds in between some of these carbons. Therefore, and this is what makes it important, they're not straight, right? You see that curves. That's got a little kink in it. And I know none of you are chemists, but try to imagine, literally imagine if I had a molecule model of this and this, and it was that size, right? I had a bunch of these, and there are models. You can be dealing with those in the lab this week. Anyway, imagine trying to stack a bunch of these together. See how high you can stack it. And also imagine trying to stack a bunch of these together. Which one's going to be easier to stack? Saturated or unsaturated? And literally, imagine it. That's exactly the shape it is. Imagine it being that size. Which one would be easier to stack? Saturated or unsaturated? Saturated, right? It's long, it's straight, easy to stack. And that's what happens in your body. That's why saturated fats are unhealthy, generally speaking. And unsaturated fats are healthy, generally speaking. Because these things, these saturated fats, get stacked up in your blood system, in your blood vessels. So that's how you get clogs in your blood vessels, because they're easily stackable. So again, for the exam, saturated fats are unhealthy, generally speaking, and they're saturated with hydrogen. Unsaturated fats are not saturated with hydrogens. They have double bonds, and they're not straight, and therefore they are relatively healthy. You do need to know the difference between those two for the exam. Are there any questions about this? Speaking of saturated fats, I guess the next word for attendance will be cheeseburger. A lot of saturated fats in cheeseburgers. Why? Because of this next slide, you do need to know this. Most animal fats are relatively high in saturated fats. So cheeseburger, obviously, is the meat is made up of an animal. And that cheese is made from dairy, right? Which comes from an animal. So high in saturated fat. And really, that's probably, if anything, that would be all I would ask you for this slide. Again, you need to know that generally speaking, fats are, saturated fats are relatively unhealthy. And as you can see up here, your textbook doesn't even mention this. Anyway, any questions about animal fats? Again, high in saturated fat. So the opposite is true, generally speaking, of plants and fish. Generally, they are high in unsaturated fats, which are good for you. And they're liquid at room temperature. There are some exceptions. I'm not going to ask you about it, but just so you know, chocolate plants are generally the exception, which is why chocolate is solid, right? But it's easily meltable. That's why that's the picture of that kid eating the chocolate that's getting melty and all over his face. It's because it's solid at room temperature, but just a little bit of heat that melts it. Anyway, as far as the exam is concerned, this is a really unimportant slide, but for your everyday life, I guess that is important. Here's another picture that's not in your textbook. I'm certainly not going to ask you this. You definitely don't need to know the difference between corn oil and palm oil and butter, but there it is. If anything, and most likely I won't do this either, but if anything, I might give you this picture on the exam and say, which of these three is highest in saturated fats, for example. You just look at the butter, right? So you should be able to decipher graphs, but most likely I'm not going to do that either because this is not a middle school class. Anyway, any questions about this? All right, another thing you may have heard of was trans fats. So let's talk about that. I'm probably, again, not going to ask you anything about that on the exam, but this is an everyday thing, so it's good for you to know. Food manufacturers convert unsaturated fat to saturated fat. Why do they do that? Especially considering unsaturated is generally healthy, saturated is generally unhealthy. Well, it keeps stuff from spoiling as quickly, and it's good for frying stuff. So that's why they do it. How do they do it? They do it in a process called hydrogenation, which you might be able to guess means adding a bunch of hydrogen, right? So again, they're going from unsaturated, which is not saturated with hydrogen, to hydrogen saturated, which has all the hydrogens it can. Anyway, when this happens, that gives you trans fats, and trans fats are really bad for you. And you can find them in margarine, certain peanut butters. And why are they bad for you? They're bad for you because they increase the bad cholesterol. So there's good cholesterol, there's bad cholesterol. This increases the bad cholesterol. So again, this is good information for your everyday life. I probably won't ask you about on the exam because this information, again, even though it's important for your everyday life, you could forget that and still understand the stuff I'm going to teach you later in the semester. So in my book, that makes it relatively important as far as the exam is concerned. So any questions about that? All right. Your book gives another example. And again, I'm not going to ask you about this. This is good for your everyday life. But omega-3 fatty acids, you probably heard about that. That is an essential fatty acid, meaning it's essential because if we need it, we need omega-3 fatty acids. Yep. And you can look it up for individual work. Why do we need it? I give you some of the reasons right here. It's healthy. It reduces heart disease. It reduces arthritis symptoms. It reduces irritable bowel syndrome. You can find it in oily fish and nuts, but you can really dive into that a little bit deeper if you want for individual work. What kind of oily fish, right? We're talking about mahi-mahi, or we're talking about salmon. And what kind of nuts, right? Which nuts have more of it than others? So look that up more if you want for individual work. But yes, again, omega-3 fatty acids, very good for you. You should eat them. So any questions about that? All right, another one. This one's a little bit more important because this one's going to come back later. Phospholipids are another type of fat. This is what makes up your cell membrane. And you're going to learn all about cells in the next chapter. So this one's important. This one's coming back. Technically, it's two fatty acids and a glycerol attached to a phosphate. I'm not going to ask you about that. They're interesting because this is a molecule where part of it is hydrophilic and the other part is hydrophobic. I'm not going to ask you about that either. For now, just know that phospholipids are part of your cell membrane. And once we talk about cells and the structure of cells, the function of cells, at that point, we'll get more detail about what phospholipids are. For now, just know that phospholipids are what make up your cell membrane. And it's in the name. So, if I ask you what type of molecule is a phospholipid, obviously it's going to be a lipid, not a protein, not a nucleic acid, not a carbohydrate, but a lipid. So any questions about phospholipids? All right. Again, I've already said this. This is kind of like a picture of everything I've just said, right? Saturated fats are mostly in animal fats. Unsaturated fats are mostly non-animal, right? So plant fats, fish fats, things like that. And again, we have margarine, which is a trans fat. It's bad for you. Also, donuts, right? Donuts are fried in oil, and oil, again, made up of trans fats. Very bad for you. Any questions about that picture? All right, there's another type of lipid that you need to know about. They keep coming, right? Steroids and waxes. Steroids. I think you guys probably know all about steroids. Your book mentions, and I'm not going to ask you this, but again, since we're talking about lipids, they are hydrophobic, right? So they don't dissolve in water. They're different than what we just got talking about, right? We talked about triglycerides and phospholipids, right? We talked about those structures. This has a different structure. I'm not going to ask you about it, but just so you know, it's a carbon skeleton that has 4 rings. So all steroids have that basic structure. Remember, last week we talked about functional groups. This is where that comes in, right? So this is the basic structure that at different steroids, they're going to have different functional groups, which makes them do different things. So for the exam, what you need to know is that a steroid is a type of lipid. So when you get the test question, says, what kind of molecule is a steroid? The answer is lipid. Not protein, not nucleic acid, not carbohydrates, but lipids. But let's talk about the different kinds. One of them that is going to be important in the next chapter is something called cholesterol. We've already talked about it before, but it is actually really important. It is the key component of cell membranes. So not only do we have phospholipids that we just talked about, but there's also cholesterol. And for now, you can ignore that first bullet point because, again, we're going to talk about cells later. And at that point, you will need to know that it's a key component of cell membranes. Mostly, I think what you need to know, if anything, at least for this chapter, this exam, is that the cholesterol is the base steroid. So there's a lot of different steroids, but your body uses cholesterol to make the other steroids. So hopefully you guys can see what these pictures are, right? You've got a male lion and a female lion. This is steroid. And steroid was used, this is cholesterol. And this cholesterol was used to make this steroid and this steroid. Does anybody guess? Anybody want to guess where this steroid is on the left? And I don't expect you to look at that and be like, oh, I know what that is, but that's a male, that's a female. Good. Testosterone on the left. Yes. How about on the right? Estrogen on the right. Good. Not that I'm going to ask you about that, but yes. And you can see, obviously, males and females are very different. And one of the main reasons is because of the different levels of testosterone versus estrogen. And look how similar they are. The only difference is here we have an oxygen double bonded. Here we have an oxygen single bonded and attached to hydrogen. Here, same story, right? We have an oxygen single bonded and then the hydrogen, and here we have an oxygen double bond. And that's it. That's the only difference. And that makes the difference between a male and a female, amongst some other things. Anyway, any questions about that? All right. Really quickly, I'm not going to ask you about this, but usually when you think of steroids, when someone says steroids outside of biology class, this is usually what they're talking about, right? Synthetic anabolic steroids. This is not in your current textbook, but there it is. If you're interested in looking into it, that's the stuff that's being used and abused. Wax. We talked about that really quickly. This is also relatively unimportant. So I'm going to teach you this because it's in your textbook, but I really don't care if you remember it or not, because the rest of the stuff we learn in this semester is not important. You don't need to know this to understand that. But what is wax? It's a hydrocarbon chain that has an alcohol group, which is an OH, and it also has a fatty acid. Animals use it for beeswax and lanolin. Plants use it to protect the leaves. And look into it if you want for independent work. The last word for attendance will be wax. So that's it for the day. For those of you who are online or in person, you need to send me those words within the next 10 minutes. Of course, if you're watching the video, there's no time. All right, so I guess that's it. I'll see you guys on Wednesday. WBSU Wednesday. Don't forget. Wear your stuff. Oh yeah, and I'm doing office hours online today, not in my office. So if you need me, come online. I will not be in my office.